Hi, this is Scott Moore of Scott Moore Consulting. You can find me on the internet at scottmoore.consulting in your browser. My handle on Twitter is LoadTester, and this YouTube channel. Please subscribe to it so you can see all the new videos that I post, as well as register for upcoming giveaways. In this video, I want to go over the analysis module in LoadRunner with version 12.53. With this version, there's a slightly different look to the HTML output report for LoadRunner analysis, and I want to show you that as I go through this. The purpose of this video is really to look through a standard analysis session and show you some tips and tricks, some things I might do to make sense of all of this data. Analysis is one of those things that the goal is not just to get a report to the company that you're working with or the project that you're working on and saying, I've run a load test, I've spit out this analysis, and here is the standard graphs that come with it. It's really about going through the data, massaging it, filtering out things that aren't as useful, and keeping the truth, let the truth of the load test come to the surface, because each performance test is going to tell a story, and your goal as a performance engineer is to make these graphs usable so that the business can make a decision. Is this application at risk? Are we going to run into performance test in production? And how do these graphs, how does this output from analysis, how does it tell us that or explain that to us? So that's what we're going to do, and I'm just going to show you a few techniques, not all of them, but a few. This is the kind of information you would get if you were getting training from me one-on-one or even in a formal training class, because these are things that I've learned over the years doing it on projects. So one of the first things that I want to show you is filtering. Filtering in analysis is fundamental to getting good information to the surface. As we look through this report, there are no filters added. This is just how it came out. Our summary report, this is basically the old Mercury Tours website where we log in and we select a flight, purchase it, and go back to the home page. I've labeled most of these transactions with an S01 for script number and T01 for transaction number, so that these will print out in the order of the business process. So that's tip number one. You begin thinking about analysis when you're scripting. So here we see a list of transaction names. Was logout the very first thing that was done? No. But alphabetically, L comes before S. So logout should be the last thing. But if you think about all of these names that I would have given this, login, continue, select flight, continue would have been the first transaction listed in my transaction names. But if I number them in such a way, or I label them in such a way where the numbering will come out as I went through the business process, I logged in, I clicked the continue button, I selected a flight, I purchased, and I went back to the home page. Then I logged out. I just did this for demonstration purposes to show you. We would have had a perfectly logical workflow to our transaction names, and they would print out the way that we want them to. Now we notice here that one particular transaction is above 1 second. Everything else is below 1 second, so everything looks really good. If I look at my service level agreement, which was defined as anything that is up to 5 users, I should expect less than 1 second response time. Anything above 5 users, I should expect less than 2 seconds response time. But as we can see, the login transaction failed most of the time. Now we do have a minimum of less than a second at some point in the test, probably early on, but even the average was above that. So it failed our service level agreement. That's the only one that we seem to be having issues with. And this is a 10 user load test. This represents the entire test. If I look at the running virtual users, you'll see that I logged up about 1 user logging in every 22 to 24 seconds to give me 3.5 minutes of ramp up time. I ran that for 5 minutes, and then I began to ramp down at a little bit different rate so that I would end somewhere between 10.5 and 11 minutes. So if we look at our transaction times, we will see averages here, okay, and the one again that sticks out, 4.4. the transaction summary is going to show how many times they ran during the entire test. So what does all this have to do with filtering? Well, if I made it to the 10 virtual users, but I can see that I have some times that do meet the criteria and don't meet the criteria, or the service level agreement did pass at some point in time, this 0.79, what I'm thinking is during the ramp up time, these timings here are probably a lot lower than they would be here. So even though I made it through most of the SLAs, I want to chop off the first 3.5 minutes of this test, and I want to chop off the 9-minute mark on, and then I want to see how that affects. So remember this number, 136, and the average of the login is 4.4. Let's see if that changes when we begin to filter things out. So let's look at the first type of filter, which is a global filter. There are a couple of different scenarios I can think of where you might want to use a global filter, but this one is very useful to take out the ramp-up time. By doing this, I'm going to weed out all of those timings that would obviously be a lot less than under load. Same thing, as I'm ramping down, the user times are going to get lower as well. So let's start where the ramp up began for our ending range. So now we have only the amount of time where everything was under maximum load of 10 virtual users. Now we look at our graph for transaction summary. It went from 136 to the mid-90s. So not as many, so that's also going to probably change our average transaction time. So whereas the login was 4.4, the maximum it's now 4.3, and probably this maximum has changed as well. The graphs that now display the global filter are going to be more accurate for how your application is going to react under load by removing those timings. So these transaction response times are more accurate. If we click on this summary page filter, which is a second type of filter, we have already applied any global filters to the summary and every other graph. Another situation where you might want to use a global graph is if you've accidentally left the miscellaneous setting on VUGen where you have automatic transaction times, and you might see the automatic transaction times listed here, like the VUser init and VUser end and the action transaction. You may want to filter those out across the board if they're not useful to you and take them out of this list. This analysis summary filter allows you to add additional filter types just to the summary page, and it will not affect the other graphs, only the summary report. The second type of filter that I want to show you is the local filter. So if you have an individual graph where you might want to take out something specific or change something specific, you can do that on that graph without affecting everything globally. A good example of that is when you're tracking Windows resources for a machine, and as you can see here, we've got several things that we're tracking here across the board that includes processor information, disk queues for the disk, memory information for page reads, and other things. So what if we wanted to take the Windows resources for this machine that we're tracking, which in this case happens to be localhost, and split out what's the CPU doing, what's the memory doing, what's the disk doing, or maybe we want to just take out some specific ones that aren't useful, that we may have tracked them but we don't need them at this point in time. So the first thing I would do is create those Windows resources graphs. Whenever I'm adding a new graph, there's no limit on how many times you can open that graph, and well, I've created 4 of them here. So, and not to be confused, what I'd like to do then is rename this graph, and I might call this whatever the server name is. When you're dealing with something like SiteScope, where you may be grabbing dozens or even more than 100 measurements across multiple servers, you're going to have to do this a lot more than just, say, 4 times, because you may have to split it out by machine and then by resource type. You may also want to create a graph where you track only the CPUs across multiple machines using Sitescope or using these kind of graphs. So you could just filter out, if you had 4 servers and you were monitoring all of them and you wanted to see all of the CPUs, but only the CPUs, this is when you would use a local filter. So there are a few ways you could attack this. One of them, it would be just to uncheck the measurements here that you don't want to see and click the Save button. However, I think a more useful way of doing this would be to set a filter. Now we already see our global filter has been applied to this, but now we just want to see the CPU processor time. Now there are obviously more things that we're tracking with the processor, and I could do that, but for demo purposes I want to create a very simple graph for you. So now the only thing that we're looking at is the total CPU usage of this machine that we tracked, and we can see that the average is only 5. It reached a maximum of 6. So unless you're looking at an application where it's already reached 100%, queuing has begun with the CPU queue, or maybe you've got an SLA for your infrastructure that says any CPU that's over 80% for a certain period of time would be a cause for failure, or it would be an alert to operations. You would be concerned about this. But in this case, I don't think we're very concerned. I would do the same thing with this one. So notice this is the exact same Windows Resources graph. It's just that I'm going to apply different filters to that local graph. In this case, what I might want to do is the available bytes that are available to me versus, say, committed bytes. Again, just for demo purposes, I wanted to create it to be simple. So now we've split these out. I would continue to do that with all these resources and then save that. The next thing that I want to show you is how to manipulate a graph from an XY coordinates perspective to further enhance a graph that would need that. And what I mean by that is, specifically, you've used a local filter in this graph for CPU. Now what we'd like to do is make that look a little better by going to the display options. Now what you might want to try here is on a single or 2-line graph, you may want to choose the 3-dimensional view. 10% might be too much. You could try 5%. I personally like the 10% view. I might also want to show the legend on the graph in case I want to take a print screen of just that one graph and send that off. But now what we want to do is go into advanced. And I typically only do this for the CPU graph. But one of the things that we know is a CPU is going to be between 1 and 100 in its value. But we see here, at first, somebody who's non-technical might look at this graph and say, well, that CPU is maxed out. And they don't even pay attention to the fact that the maxed value is in the 30s for whatever it's showing here. And even though it had a max of 61, that particular data graph is not being captured because it's doing sort of an auto sizing for this graph. What we're going to do is force it to choose a value in the axis that matches what we want. So we're going to change it to 0 because that's the lowest value that a CPU could possibly be. And then we're going to change the maximum to 100 because that would be the true maximum value of a CPU. So just by making that change, we can see that this more closely resembles what the machine was doing under load, which was not very much. Yes, there was an initial spike, but it was only at 30%. We still had plenty of headroom. Now a non-technical person on the business side can look at this and say, oh yeah, this is nothing, right? Whereas the spike would have raised questions possibly in a meeting. Another trick that I might go into the advanced display options for is changing colors as well. In this particular graph for the memory, we only have 2 lines, but the colors are kind of close together, at least in my opinion. I like to have very distinct colors so that they're easy to see and show what they are. So in this case, I might go into display options. I might also choose a 3-dimensional, so especially if we had some that were kind of running closer together. So in this case, I would want to go into advanced, and I would want to go into the series here. I would double click on that first line that is showing me the available megabytes of memory, and I would change the color. Let's choose something really bright. Then let's go back, and now we've got a contrast between the two. I could change each one as well, but only one would be needed to create that contrast. Also notice that the series of what this is called has a very long name. You might want to actually change those names as well, and you could do that by clicking on the title and taking something out to make it shorter when you printed a report for it. So it's worth going through the editing of the properties and the advanced display options to make your graphs look a little better. You may also want to add something like an arrow or a comment to this. So if I wanted to draw an arrow, I can simply click on this icon, click on a left click and drag towards the area that you want to point to. Now you have an arrow, and you can move that arrow around however you like. But now what I'm going to do is just point that arrow there and add an additional note and say, this is not a problem. So that when I actually put my analysis report out, they can see actually on the graph that there's no problem. The only thing is I don't like where this is located, so I'm going to change the position by fiddling around with the up and down arrows and getting this exactly where I want it to be so that you can see the note pointing to the arrow, pointing to the location where there isn't a problem. If that were a serious spike, obviously you could point that out, and now non-technical users at a glance can look at this graph and see there's a problem or there's not a problem. And I know this is for this particular server, which might be the web server, and it's the CPU that's the problem. So as you can see, load runner analysis can be very powerful. I've only touched the surface here, and when you've made all of these tweaks and changes and you've saved your analysis session off, the next thing you're going to want to do is export it somehow. So there are reports that can be customized for different formats like PDF, Word documents, etc. And you can customize them any way you want for a business format, customer format, technical format. If you want a quick report with all these graphs in HTML, you can click on that HTML report link. Now notice that you already have in the folder where your analysis session is, you already have some HTML in there. Those are actual graphs that you're seeing in the analysis session. So for example, when you look on the summary page of this analysis session, that's actually displaying, and portions of it, I should say, are HTML. So what we don't want to do is click on a name like that and overwrite it. That would be that would be deleting it, and we don't want to do that. So what I always do when I'm creating my folders for my Load Runner project, I'll have an analysis session folder to save the session. I'll save the results of the raw results from the controller in another directory, and then I'll have a separate folder just for HTML. And in that case, it's okay to call it the same name as you found in your analysis session. I had already saved that previously, so I can save that and see this new format of the HTML report. So mostly it's over here on the left-hand panel. We have just a slightly different look and feel. Some of the graphics I think may be a little bit better, easier to see, and also in my opinion, it seems to generate a little bit quicker as well. So you could store this out on a web server, and you would have easy to get to report that people could export into Excel if they wish to, and sort the data even further if they wish. So finally, the last thing that I want to mention is, once you've created this wonderful report, you may be working on a project where you've just run your first test, and now you're going to need to make some changes to the app, rerun the test, and then rerun an analysis. If you've spent quite a bit of time, say an hour or two, making these tweaks and changes, you definitely don't want to redo that and make that effort. This is the reason why session templates are so important. So if you go to Tools and Templates, you already have a default template, which is when you load up your first session, you'll see the initial reports run up there. But we want to create a new one. So let's create a new session, and we can just leave that as its default. And I'm just going to save it in the regular place where it wants. What we've done is we've created this particular template, and see, it's got our custom names here for our graphs. So now it's there. It's not the default. We could make it the default if we want to. If that's the only project we might be working on for a while even, we can make sure that by default it continues to load these up. So we're saving that template, and at this point, when we close down and we open up a new raw session up into the analysis, it may load up with the default. You can then go to templates, select this template, apply it to session, and you can also take off automatic granularity if you would like, but you will get the ramp up, ramp down chopped off. You'll get these colors. You may have to come back into it and tweak locations of some of this because some of the measurements may have changed, but it will then be easy for you to compare between two analysis sessions, two different test runs, etc. I hope you've enjoyed these tips and tricks. I welcome your feedback. This is the kind of thing that I would do in a typical mentoring session or a training class when we go over the analysis module in LoadRunner.